We are online at 2,600 and about 60 kilobits per second. And the quality is transcoder enabled. Hello. We're on stream number 9. I'm porting a grammar from GNU Bison over to Rust using a Lawler pop. Working on a tool that can compile a domain-specific language, kind of looks like this, to describe binary data of any kind. So, for example, we have a GIF file here, and its format can be specified thusly. So, overall, the file has a header, a logical screen, 0 or more data blocks, and a trailer. And the tool that I'm building will use this specification and this raw data and spit out what's in it. So kind of looks like this. Signature matches that from here, followed by the version number there. Hey there, Stick Streaming. I'm doing well. Just getting started. Do my traditional intro spiel for anyone who's watching the VOD. I figured that if you're watching live and you didn't come in right at the beginning, then yeah, you'll have to wait till the next time that someone, like enough people come in and I remember to start giving the intro. Otherwise, you could just try to figure out what I'm doing. I'm basically today going to continue the work porting this set of grammar rules from GNU Bison over to Lollipop in Rust. So let's just show an example, like op ID list. So an optional list of identifiers could be either empty or it could be left and right parentheses with an ID list in there. So that looks like this. It's either empty, and a Rust version of empty is just empty parentheses or the unit. And then the other grammar rule, the other alternative is this, where we have literal tokens left and right parentheses, and then another grammar rule, and we extract out that ID list to return it as the output of the parser. So the output of the parser overall is going to be some type which represents the it's like the compiled version of the program. We call it the abstract syntax tree. So if we're just parsing an optional ID list, you get out an optional vector of strings, because an ID list is a vector of strings because it's a list of IDs, and IDs are strings. Makes sense, right? So I'm starting with the simple grammar rules, and we're building up the top level grammar. I can show you it's a sequence of format specifications. So I'm using I think it's a standard technique of forming lists in GNU Bison grammars. So your list can be empty, or your list can build in a chain. So it's a recursive specification. See, formats lists itself there. So you can imagine the first format would be empty, and then you'd have another format after it, and then that together becomes another format, which then you build onto, etc. And then we have a special third rule for if we find some kind of syntax error. Sounds like minimal version of x64dgb and a very understandable. Cool. Yeah, so the whole point of this is to build something like what Wireshark has for plugins, where if we're looking at some binary data and we know that it's a certain protocol, that you could click on a byte or a range of bytes and it would show you what it means in another panel. So I don't have this kind of user interface like Wireshark does, but I eventually do want to have that. We're starting at the engine, and then we're going to build off of that and eventually have a user interface, kind of like this. That's my goal. And the project was originally written in C and C++ like 5 or so years ago. So that's why to make a compiler and a parser in C, one popular way is to use flex for the lexer. So it's basically just a series of regular expressions and then code to run whenever that regular expression is matched to form a token out of a sequence of characters. So like a literal floating point value would, if it matches this, we kind of extract out that text that matched that regular expression and turn it into, interpret it as a float. So for mine, I should probably open that. Using a similar technique, but we're using a crate called logos. So in there, the equivalent is down here, so up, right here. So it's the same regular expression that we had here, only slightly different syntax. So instead of curly braces, it's parentheses, question mark, and instead of just being a bare regular expression and then some code, with logos crate, they use attribute macros for the variant of an enum, which is kind of cool. I think it's more compact. These character classes we define at the top here as a subpattern, along with how we define white space. And yeah, another thing to mention is we're having special tokens for special kinds of errors. The original Lexer did that too. So we had like anything that's not matched with those patterns is an illegal character. So I have the same thing. And then originally I would catch a bad string if it was missing its end terminator, right? So we're doing a similar thing here, unterminated string. And then this is sort of new, something I didn't do in the original Lexer, which was not that it's unterminated, but that the string has something else bad in it. So, for example, in the original Lexer, when we're parsing string content, you can have an escape sequence, and you might have like say an octal escape sequence, but then the next character is not between 0 and 7, so it's like not a legal octal code. We just spat out what we had so far, and then didn't interpret that character as an octal at all, so we backed up. So I decided instead on mine to call it an illegal sequence. So the equivalent of that is up here somewhere. So if we're in an octal and something can't be converted to a digit in base 8, then we call it a bad string error. So far I have 4 grammar rules. I don't know exactly how many I had, but the grammar file is over 1,000 lines long, so there's quite a few rules. And yeah, I'm basically going through from the leaf nodes up, basically, because it's hard to go top down. We can't test if we go top down very easily. So if we try to port formats, it won't actually even compile until I define what a format is. And a format, we can't specify, we can't test this until we have statements, and statements doesn't work until we have statement, and statement doesn't work until we have statement body, and it just keeps going, right? So top down, it's hard to test at the unit level, so we're going bottom up instead. So yeah, skipping all of these that we can't do, we have ID list, because ID list is just based off of elementals like comma and identifier. So comma, identifier, and then it can be self-referential. An optional ID list, talked about before, it's just 2 rules. It's either nothing or it's an ID list in parentheses. One kind of weird thing about Lollipop is that there's a little bit of extra separation between it and the Lexer. So I'm used to, in the Bison grammar, being able to use the actual same symbols that I, for the parser, for the input to Bison, I was used to being able to use the same exact words that the Lexer has. So if we define a left parentheses with L paren all in caps, I was able to just use it as is in Bison. For Lollipop, there's an extra separation. We have to use a string here, and then we have to map the string to the actual variant of the enum in this extern section. Hey there, Sarian. How are you doing? And you can see, and this isn't an exhaustive list yet. The actual list of tokens is quite big. It's this whole long list. So eventually, when we have all the grammar rules, we'll have all of them in here, but these are just the ones we've needed so far. One thing I wanted to test before I go, yesterday I was reading through Lollipop's grammar in their Git repo, and it says something like, we don't have to give it a name. If we just do this, it should just extract the name. I think I'm going to test that theory, so we're just going to run the tests again. Nope, I'm wrong. Not found in this scope. Cannot find value ID list. So it's there's that test. So maybe I misread it. Little tired after helping to collect up 26 bags worth of litter earlier. 26 bags? Wow. I'm not that tired. I did have some, I don't know, wasn't feeling well last night, but I just got extra sleep and I seem to be fine now. You have to be careful when you get older. Pay attention to the signals your body gives you. Otherwise, your body kicks your ass, literally. So yeah, I got some extra sleep. Extra sleep is usually a good compensation for if you did something wrong, like you ate something wrong or over exercise or something like that. Okay, anyway, I'm kind of interested to see, maybe it's sort of like this, but I just don't have the right syntax. Is this WebAssembly? No. Hey there, Saif. Ashraf, Helmi too. This is a grammar specification that's used by the Lollipop Rust crate. So Lollipop is a Rust parser generator framework. So it's kind of like old school grammar parser generators, which used a Bacchus-Nor form of describing the syntax of a language. So it's like given an output thing, I guess you call it a component of a programming language, like what the inputs could be. So like a sequence of format specs could either be empty, or it could be a previous sequence and then one added to the end, or it could be like you found a syntax error. Format itself is an identifier, optional identifier list, a left brace, some statements, and a right brace. So that kind of matches my language here, where we have an identifier, a left brace, some statements, and a right brace, right? In Lollipop, which is, again, it's a Rust crate, so I'm porting this from C to Rust, right? In C, I used GNU Bison. In Rust, I'm using Lollipop. The overall structure looks very similar. So, like ID list is either empty, an identifier, or a previous ID list, a comma, and another identifier, right? So in Lollipop, this is what it looks like. So it's empty, an ID, or a previous ID list, a comma, and another new ID. So it looks pretty similar, maybe a little bit more compact. Certainly, there's less I need to do when the rules are matched, because we're leveraging things like the vector macro. We can put things on a single line. It's much easier to form a list in Rust than it is in C. In C, there's no built-in type for a list, so I just made it a linked list. So we have to manage like the last and the next pointers, because of course you got to make it doubly linked, right? Yeah, it's much simpler in Rust. Sounds so complicated? You prefer JS? Okay, well, how would you make a compiler in JS? I imagine you'd have something like this. It would just look different. So I am making a compiler whose output is used to parse binary data. So here's like what a GIF file looks like in binary. And my tool will compile this specification of GIF and then use it to parse the GIF so it'll look like this. So like when we parse through the header and we see that the first 24 bits is a string signature, indeed, first 24 bits is a string signature GIF. The next 24 bits is another string 89A for the format. So the goal is to have a tool that I could specify the format of any kind of file or protocol or whatever binary you have. And then the tool will be able to parse it, basically decode the file into its elements. And if you were to do it in JS, you'd have to do something similar, right? Yeah, I'm definitely making a new programming language and parsing it. Yes. Not really it's not general purpose, it's domain specific. So it's specific to the description of binary data. So you wouldn't be able to use it to make a game, but you could use it to parse the save game file, right? If you knew how the structure of a save game file and you could describe it in my language, you could use it to like find out how much gold your characters have, for example. Maybe even hack your save game file to change the number of gold pieces your characters have. Not saying I didn't do that for the game Wizardry in like back in the 80s, but yeah, you can do that. You find the byte in the file, which literally stores the amount of gold or the amount of experience points your character has, and you just hack it to be like all ones, and now you have billions of gold, and now you don't have to grind anymore. I think modern day save game files would have a checksum or CRC attached, so you couldn't just change the byte that holds your number of experience points in gold, because then the checksum check or the CRC check would fail, and the game would say this game save is corrupted. So these days you probably couldn't get away with it, but old school games didn't have as many CRCs and checksums, and you could totally hack them. Just use a cheat engine. Well, how do you think cheat engines work? Someone had to reverse engineer the format of the game, either its protocols or its save files, and to figure out where things were in the protocols or save files and be able to change them. It's exactly what a cheat engine would be built from, the knowledge of how things are constructed. So that's what my tool is able to do, although we only use our tools for good here. So the intent for me is that I would describe like the formats for like files and protocols and other things in other projects that I'm working on, so that if I ever need to debug an issue that involves data that otherwise is indecipherable to me because it's all just binary, I could use my tool to pick it apart and turn it into a text format of that, where it's more likely for me to find a problem, right? If I can not only read what the bytes mean, but where they are in the original file, and then I can go in hex editor and change them if I had a bug. So yeah, the three elements of my tool are the lexer, which turns the program describing the data into a sequence of tokens. That looks like this. Oh, not that one. Try that again. No, not that. Oh, I have to do target, right? Target. Nope. Maybe not. I guess I don't have it in my history, so I'll just type it stage gif.fmt less. Right, so the lexer is the first part. It turns this sequence of lines of strings into a sequence of tokens, right? The second part takes this token sequence and uses grammar rules to reduce it down to the data tree, which is the memory representation of the compiled form of this. So for my case, it's going to be at the top level, the root of the tree, it's going to be a formats. The next level is going to be one or more format. And the format has all of the statements to execute for different kinds of formats. So you can see how this might work, right? If this sequence of tokens is a format, well, that identifier is GIF. There is no optional ID list because we didn't have a parentheses. This left brace is here. Statements goes until the next right brace, so it's way down here somewhere. I think it would be right around here. There it is. That's that right brace, and then everything in between. So all of this constitutes statements, which is itself a grammar rule. So this reduces down to a list of statements, You kind of get the idea, right? We're turning a token list into a tree data structure, which we'll be able to traverse in order to parse the data, which is the third step. After we get the parser done, we've compiled this into a binary data structure. So we've compiled the program. We use that structure, which sometimes is called an abstract syntax tree, and we'd walk through these bytes with it to interpret all the bytes as the different pieces. You're a civil engineer, and you're here in a software and game dev stream. Do they have civil engineering Twitch streams? If not, maybe we can start one, and then you could stream in that. I'm not sure what a civil engineer would stream, though. Would that be like doing CAD stuff, like designing buildings and stuff? Stream reminds you of your compiler constructor class. Yes, exactly. Do you remember this book? The Dragon book? So I learned from that. And that's actually one of the reasons why I made this original lexer and grammar to begin with. And now here we are in 2023 porting it to Rust. Heard syntax tree before. This is what the V8 dungeon, well, any kind of compiler would do this if it's made in the traditional way. Of course, you can have non-traditional compilers that don't have a syntax tree, but a lot of them do. You have the second edition? Yeah, mine's the first edition, man. It's like it's worth money now. Your class used a different textbook is not a great class. I'm just kidding. Okay, so today I'm working on a couple things. This seems redundant, and it looked to me like there was a way we could just reduce it, but when I tried that, it didn't work. So I got an error saying that not found, right? Couldn't find it in scope. And it's this part that doesn't get, right? So maybe this needs to change. Maybe this is okay, but this needs to change. I was going to peek into their, where is it? Yeah, their grammar. Or maybe it was their tutorial here. I didn't like their tutorial because I can't really find anything in it. It's not easily searchable. I kind of have to look through it linearly to find what I'm looking for. You only know Rust from Primogen. Rust is pretty cool, in my opinion, because it's very strict in its types. And you can do cool stuff like this. You can make a type, which is a enumerated type, which has not only the values, the variance of the enum, but you can attach data to them. It's kind of like a C union coupled with a discriminator all in one. And the really cool part is you can use macros to generate code with just a single line. So this single line generates 4 different trait implementations. So it makes the type clonable. It makes it so that we can print it in debug statements. It generates a lexer, which is super cool, which is the whole point of the logos crate. And it generates code that you can compare values of this type. So it's hard to do all of this in like C, C++. You generate a lot of boilerplate in order to do this. Single line in Rust. Yeah, and just in general, the like testing is much nicer. Here, let's go to the tests. I need to go to this anyway. So like, let's look here. Asserts are kind of built into the language, whereas in C++ you have to pick up something like Google test to have this. This test case crate allows me to have the same, sort of like a template test, and have different inputs and expected outputs. So like if the input is empty vector, the output should be it's okay, but there's nothing in there, and name the test empty. What's really sweet is when you use plugins for your editor, and it doesn't have to be VS Code, it could be Vim or Elm or you know whatever, right? Emacs. If you have, if you're using Rust, there are lots of editor plugins to do cool stuff like this, where I can just click this and it just runs a test, right? It actually can't run because my code doesn't compile. But if my code were to compile, I could just click a single button to run a test. And if I like add the 2, look, it updated it automatically. Isn't that sweet? It's cool stuff like that. Also, like there's a built-in formatter. So if I screw up and put a tab in there, it does that. If I like add a space here by accident and just hit save and it fixes it for me. Granted, other languages like JavaScript also have this, but I'm just not used to this level of sophistication with C and C++. Why do you test your own project? Why wouldn't I not test my own stuff? Don't I want it to prove that it's working correctly? A type with the default values included. Yeah, you mean like a type that generates code to generate the default values for that type? Yeah, you can do that too. But yeah. I can't really show it here because I haven't gotten to it yet, but one of the main reasons I like Rust is the compiler is very, very strict, and most bugs it will not let you compile. Whereas in C, C++, it lets you get away with it until runtime, and then you have crashes. Then you spend a lot of time trying to figure out why your program crashes, only to discover that you went outside the bounds of a buffer, and then you're like, well, in a modern language like Rust, that wouldn't even compile, so why don't I just do that? There's a lot of strict type checking, a lot of static analysis that Rust does that other languages don't do. Now, there's a flip side to that, which is it's super hard to learn, and it's much harder to get your code to compile, which I'm sure you've seen Primogen struggle with also. So it can be kind of annoying and frustrating at first when you're like, I can't just tell the computer how I want my program to run. I have to be it's very, very, very nitpicky. And that can get kind of frustrating when you're like, compiler, just tell me what you want me to write. All right. So let's do another grammar rule. I need to pick one that doesn't need something I haven't written yet. So none of these will do, right? Do I have op look ahead? Yeah, I do. Op ID, I know I have. Op assign, let's do that one. Oh, I can't do that because we don't have ref. Can't do op bound because we don't have expression. Can't do this yet. I think we're probably going to be doing key values next, because then we do key values, then we can do interp. Oh, we don't have op comma. We can do that one. I can do all these optional delimiters and stuff. Where's op comma? Up, comma. Where are you? Here it is. Super simple. It's either nothing or a comma. What could be easier? Start with something simple to get the blood flowing, right? Comma. So we have to make the module, and then in the test file, actually this needs to go in that test directory. And in the tests, we declare it op, comma, go away. So we'll also need to add it in the grammar. Op, comma. Does this actually need to produce something? Or was it just there for, yeah, it's just there for delimiters, so we can just have this produce nothing. So this syntax here is Rust-like, but it's not Rust. It is input to a Rust code generator in Lollerpop. So the Lollerpop crate at build time, I can actually show you what it does. So at build time in our build.rs, it's going to run this process route off of the Lollerpop crate. And what that does is at build time, it looks and finds all the .lollerpop files that you have. And between grammar and extern, it's going to interpret all of this as a special language, its own domain-specific language, which has a grammar file for which we could look at if we wanted. So it's Rust-like, but it's more... It's like a combination of Rust and Bacchus Norform, like we had in GNU Bison, where it's a bunch of rules with alternatives that have sequences to match. So it kind of looks like a match, but it doesn't. It's got extra syntax in front. It's kind of weird. It uses these brackets for a certain meaning. So for us, we're going to generate nothing, and we're also going to generate nothing if there's a comma. So this grammar rule basically eats an optional comma and tosses it. It's only used as sort of like a way to disambiguate other grammars. Rust error codes are confusing when first getting into the language. It depends on what kind of code you're trying to write in Rust, I guess. If you jump straight into lifetimes and async, you're just asking for trouble, Mr. Hodgepodge. If you start with something simple, like hello world, and you misspell something or you leave off a bit of syntax, I think the error codes are actually pretty helpful. The error codes can be really difficult to understand for the async code and for lifetime code, because that's really hard to get right, especially when it's being shown to newcomers to the language. If you know Rust deeply, the error codes, you can kind of figure them out, but those are really hard error codes to describe in simple language, right? So I made this grammar, and it's super simple. We should still have a test for it because, like I was saying to Scheif, why do I test my own project? Because I want to verify that it works correctly before I start to build bigger and more complicated things. General rule about programming: test often, test early. If you don't write any tests for your project and you just like try to build something huge with it, and then it just falls on its face and crashes and burns, where are you going to start looking for the problem? Versus if while you're building something up, you're testing all the individual pieces as you're going until you get to something bigger. Probably it'll just work. If it didn't work, then it was wherever the bug was introduced. Hopefully you'll catch it in its own unit test. If not, you'll catch it one level up when you try to use it with something else before you're building something complex where it's difficult to figure out what actually broke. Okay. Yeah, so in op comma tests, we want to have some tests. There's some boilerplate here, so I'm just going to copy paste from something else. Actually, look ahead is better because it's closer. It's closer in form. Oh wait, I forgot to clean that up. We can now say this use superstar, right? Here to get rid of a lot of this boilerplate. And I should do the same thing here, right? We don't need this stuff. Just use superstar. Okay. So again, superstar. Brooke Zerker, you're always rating me, and I have very little opportunity to rate you back, but I hope your stream went well. I know you're working with SquealX. SquealX. I saw that in your stream title. I like calling it Squeal now. Ever since the Primogen's stream, he was calling it Squeal. I'm like, that's just an awesome way to say it. It's not SQL, it's Squeal. And it's not SQLite, it's Squealite. Yeah, everyone, you should watch Brooke Zerker if you have a chance. Especially if you want to look at like educational, like learning, training stuff for Rust. So there we go. Working with testing SquealX. Yeah. What does the X mean in SquealX? I know what Squeal is. It's a structured query language. You watched Brooke Zerker once. Only once? That sounds ominous. Like I watched him once and then Dix means it's cool. Sure. All right. I'm down with that. Yeah, so I am working on the grammar for a compiler. I have a programming language. It's not general purpose, it's domain specific for describing how data is structured at the binary level. So here's an image in a GIF format, GIF or GIF or GIF if you prefer. And if we didn't have a viewer to see what the images looked like, or if we just kind of wanted to quickly like get some information about this file, like maybe how big the images are, the tool I'm writing would be able to do that. If you could describe the structure of the file, it kind of looks like this when it runs, like this. So it's able to say like, okay, the first 3 bytes is the header's signature and then the version number. And then a little bit further down, it's able to see, well, the height is 300 and the width is 300. That's in here somewhere, right? In this, oh, whoa. I think that's a bug. Look at the crazy highlighting colors. That looks like a bug in this plugin I'm using for VS Code. Wow, freaky. Anyway, hopefully it doesn't crash my VS Code, but if it does, no biggie. Yeah, so I wrote this tool in C about 5 years ago, and I'm porting it to Rust. So the original tool used Flex and Bison to describe the lexer and the grammar, right? Using Bacchus-Norform syntax for the rules of the language, and I'm converting it to Rust using a combination. For the lexer, we're using logos, which is pretty sweet. You're just basically adding attribute macros to an enum, and now you have a lexer. And then for the grammar rules, it's a little bit more involved. We're using Lollerpop. So it generates Rust based off of grammar rules that are Rust-like, but also have some elements of Bacchus-Norform. So you have like the name of the grammar and then its output, and then you have the different rules that would reduce to that grammar. But it's also kind of Rust-like because the outputs are all Rust expressions, and yeah, it kind of looks like a match expression itself. So I'm going through all the grammar rules of my old compiler and translating them over. Yes. Have you seen my keyboard? Developed that last year on this stream. Built it myself. 3D printed the plastics, had the designed the PCB, had it built, fabricated for me, and did all the soldering. Did all the design of the and development of the firmware here on stream. So it's a fork of a fork. Squeal X is based on Squeal C from Go, which is a fork of Squeal X for Go. Okay. I took a look at Go a bit ago, and I saw what I did there. It seemed okay, but I didn't really get into it that much. Is it easier than a normal keyboard? No. This is a 36 key keyboard, so I have a lot of shift keys on my thumbs, and I built it myself, so the quality isn't perfect, but you know, I have to live with what I made, right? I like it though. I like challenges, and one challenge is to actually use what I built. Okay, so optional comma should be super easy, right? So either we have a comma and we get nothing, or does this actually matter? Too many tokens test? I guess so. We would have the output is an error, too many. We expected nothing. Invalid token, integer. We expected a comma. Okay, test case no comma is okay. We don't distinguish from a comma or no comma in this grammar. It's just nothing. And then this is test optional comma. Use the comma parser. Okay. This should say comma. The expected output is nothing. So let's do a cargo test on that. Oh, I messed up my grammar before, right? I was playing around with this. Let's put that back in there for now. Hey, look at that. We passed first try. So now that it's building, I can show this again, where if we wanted to, we can run all the tests, or we could just run a specific test just by pressing a single button. Isn't that cool? Go seems nice for writing a thing quickly. It even lets you write asynchronous quickly, and it compiles quickly so you can iterate quickly. There's a lot of quicklies in that statement. But when you want something to run quickly and don't mind how long it takes to compile, you may want more strict typing with type spacing. Rust seems like a better choice. I guess it depends on what you're writing, right? I've seen people who write Rust very quickly for specific goals because they've written a similar thing before and they can either copy paste a large part of what they need or they just know exactly what to write. Rust is actually pretty compact syntax compared to some other languages like C++. C++ is like the king of boilerplate, right? You can do a lot more with the same number of characters in Rust, but I guess I would concede you know better than me. Maybe Go, you need to do even less typing. And maybe you can be loose with your types so you can make some mistakes and yet it still works. For good is something that will be faster. Yeah, that's what I was thinking. Like, I don't know if I'd pick my language based off of how quickly I can, in general, make things with it. I'd want to consider like the other aspects of it. I don't know. I don't mean to argue. I'm sure Go is great for fast prototyping. Can't the same be said with Python? I've heard that before, that some people like Python because you can write stuff in it really quickly. The compile time speed, though, I guess if you care about that, I don't know. I'm not in that camp. I don't really care about how long things to come. If something takes longer to compile, for me that means I get to go take a break for a few minutes. Maybe go get a cup of coffee. Maybe go meditate outside or something, go on a walk. I actually don't mind things compiling, taking a while to compile. But I hear you if you're doing lots of iterative development and the compiling is slowing you down. And that's actually kind of like why I'm a fan of doing these very focused unit tests, because like these compile and run really quick. I can change this to a 3 and look how fast it ran. It was like a second. It took a second to compile, right? No, it took less than a second to compile. Plenty fast for me. And this doesn't matter how big my overall project is. This unit test is very focused on one module. So, and Rust has that, what do they call it? Incremental build architecture. So it only really needs to compile the one module that my test is in. Plenty fast. Skill level 2, you're much better at Rust than Go because you have more experience in it. We could always turn that around and say maybe you should write in Go to get more experience in Go. Then talking about compile time, I don't mind that personally. Might matter in some situations though. Yeah, I think that's what I was saying. I think it matters when you really are iterating fast and you want to try something really fast. Cargo only compiles files that have changed at first. Time compile can still take some time. Sure, but then, you know, everyone needs to take a break every once in a while, right? There's an XKCD comic about that, right? They're like sword fighting, and the boss comes in and asks them what they're doing, and they're saying, we're compiling our code. What else are we gonna do while we're waiting for the compiler? Okay, let's move on. What's next? We have an optional comma. Super. I actually don't even remember where we use optional comma. Okay, we use it for a literal set. Oh, okay, I am allowing an extra comma after an expression list, but before right parentheses. All right. Ah, yes. Version control cleanliness. The last key value can end in a comma so that if key values are each on their own separate lines and another key value is added in the future, the line containing the formerly last key value does not need to be changed. Okay, have fun in your meeting as much as you can. Just remember, you're getting paid. It doesn't have to be fun if you just think of those muns that you're gaining. I actually have a meeting in an hour, so I can go for about 45 minutes. Oh, yeah, we're down here, right? Optional comma, right? Do I need a string grammar rule for this? This expands in the string token by catching common errors such as forgetting a string terminator or having a similar error which is detected by a missing string terminator. Okay, so I guess the way we would do this is we would pass a string through as is, but if we run into a bad string or an unterminated string, we would actually reduce it to a string, but we would generate an error, right? Hold on, archification. Do we really want to hope for a promotion? You know what promotion means, right? Promotion means more responsibility. More responsibility means more work and more stress. How about we just wish Brookzerker a raise, and then if he wants the promotion, fine, but, you know, promotion can be a bad thing. I'm speaking as someone who doesn't want to be promoted because I'm perfectly happy with my stress level. Just give me more money. With responsibility comes responsibility. Yeah, I'm too responsible. I don't want to be more responsible. I'm responsible enough. But I guess we'd have to ask Brookzerker if he wants more responsibility or if he just wants more money. How about give me a demotion with a raise, right? Less responsibility, more money. Perfect combination for me. All right. Too bad the world doesn't work that way, right? I think we have to start doing more complicated grammars. I think I'm going to wait on the string because I'm not sure I need it. Let's wait until we've run into the situation where an actual string grammar rule would have been useful. And instead, wherever we see string, we'll just substitute capital string, the literal. So the expression's scary. How about I do, yeah, the token. Actually, key value uses expression. We might have to do expression next. Or maybe ref. No, ref uses expression. I think we have to do expression next. This is going to be a tedious, long one, because look at all the different expressions we can have. That's just going to go forever. I know what we can do. We can build up an expression from different parts of the rule. So we can do like just this one to start with. And actually, we can just start with literals, right? Where would we find that? Here we go. We can start with an expression can be a literal, integer, decimal, string, or the nil keyword, and then just go from there. The borrow checker in Rust helps abstract away responsibility, right? I can't get the borrow checker to come with me to work, though. Good one. Not my joke, but yours, Arch. Okay, pub, expr. So what type do we emit for an expression? I think we need a new kind of type for this, called the expression. So in the old C code, I actually had an expression type here. It had a type, which could be operation, a literal, a function, and you could have this. You could form it in a list. It could have a sub-expression. I don't think we need to have these because like Rust containers take the place of that. The fact that I have a union here with a discriminator means I probably want an enum, right? Okay, so Cool. This is the first time in the grammar we're going to introduce a new type, right? So I probably should look at the tutorial to see how did they do that. So we define it where? We put this code into a RS module along with some debug stuff. Oh, and then we use it. Okay. So once it's been used, we can put it in the syntax then. Okay, fair enough. So let's do the same thing. So that's even before we get to the grammar rule. We need to make a type, right? I'm trying to think, should I put it at the top level of parser? If we're gonna have a lot of types though, might want to have a submodule. They had a submodule called AST. I think I'm just going to call it expression. And then we'll have pub enum expression. Let's see what we can get away with without expanding the code, without generating any code from it. We'll just have literal. Let's follow along what I had in the C code, actually. So I did actually have different things. Well, actually, yeah, we do. We have to have that, right? Literal integer. And then this would be I64. Let's just start with that minimum. You do understand people who say that writing Rust is slow. Once you understand it, it's just as fast. Granted, those kind of posts only started appearing in 2019. Remember, because you're 8 years into writing your simple calculator Rust, you're 35% done already. Nice one, Zivar0. You don't always make good jokes, archification, but when you do, they're good. Yes, by definition, any good joke archification makes is good. All right, so then I should be able to say use. We're at the same level, so I should be able to use expression. Okay, and then yeah, pub expression. So we have integer, I guess. Oh, this one had attached data, right? We do that by putting this I and then that. I. Okay, and then, but hopefully I did this right. We can just make under tests an expression .rs. Let's steal from op comma since it's really easy. Copy paste. I have to under tests say that we have a mod exper. Also at the top I need to say we have an expression. So up here we need to say that. I don't like the order of this. Let's do that. Okay, and then mods first or uses first? Uses should go first, actually. Although now I'm starting to second guess myself. Maybe mods should go first before uses. Maybe. Yeah, undefined behavior could occur, and that would be terrible with a joke, with a good joke. Honestly, I feel like most people say writing it is slow, haven't yet fully understood how ownership works. Yeah, I agree with that. I think part of the problem is that in the learning material for Rust, they don't emphasize ownership enough. And the concept of ownership in Rust is essential to understand, and it's different from other languages. I could argue that in languages like C and C++, the compiler has no notion of ownership other than if it is a local variable. And the moment you take a local variable and you give it to something else, now the compiler has no idea who owns it. Right? If there's no notion of ownership for parameters in C, it has to be built on top of what you tell the compiler, which means the compiler might be compiling code that's just wrong, right? It assumes ownership when it doesn't, or it owns it but doesn't clean it up, and then you have to manually free things, and it's a mess. Does FMT or Clippy have an option on use first or mod first? I don't think so, because when I'm saving, it's running FMT, and it's not rearranging it. It's removing the excess white space. Is all it's doing. In fact, it doesn't even mind if I have no spaces between my uses and my mods, so I don't think it cares. All right. Let's get this going. So, comma, expression, right? So, valid expression right now is token integer. 42. Should give us an okay expression. Literal integer 42. Do I want the too many tokens test? I suppose so. So that goes there with a bar after it. Too many tokens. Okay. Invalid token. Comma. And this was like integer, right? It'll make room for there being a list, but right now the only thing in the list is you can have an integer there. I guess we should have an empty test, right? This is an invalid test, and I actually don't know what the error will be, so we'll have empty. I don't think we allow there to be an empty expression. So this is op expr. Kind of feel like most of this is the same for every test I've been writing right now, and maybe I should be like calling some kind of common test thing. The only difference being that this is different and the name is different. I've always done mod first, you can keep all your use statements together, just makes sense to me. Yeah, I've been doing it the opposite way, but I'm second guessing myself now. Okay, compiler error. Terminal integer does not have a pattern defined for it because I didn't put it in the what do you call it? I didn't put it down here. Integer. I64. Expression needs to actually import the type. Expert needs to import expression. What's the error there? What? I think it's confused there, but I could be wrong. Mismatched types. What? Oh, it's not optional. Yeah, I just didn't see the op. It was my brain just totally didn't see the op. There's no op. It's expression. Okay. So what's the problem with this? Okay, because this should be expected an expression. So that if I were to make some common boilerplate, this would change and the name would change and then this would change. Another error. Right, so I guess that's vec. No. It's not okay. Let's just, I'll put in like, put that in there. It's not an unrecognized token, but I'm just too lazy. Crate expression? Wait. In the grammar. Okay, so yeah, because it's a submodule, right? So I have to do that. Okay, so not being formatted with that means I need to derive debug for it. I was saying earlier, what can I get away with on expression? And that's what we can't get away with. So we have to have cut half an hour. I have to do a derive at least for debug. Okay, we need partial equal. It's probably going to want me to implement clone as well, right? No, it didn't need me to implement clone. Okay, cool. So the only thing that failed was that one I knew would fail. The empty expression, right? So this one, it's unrecognized EOF. Interesting. Expected integer. Yeah, so it's just that. That's different. Okay, also there's also a location. But before I get too much further, I'm probably gonna want to fix the location thing, right? Because that's gonna be copied everywhere and it's gonna be really annoying. Hey, look at that. We successfully parsed an expression, which has to be a number right now. Thing is, I don't know if I know everything I need to know about what type to use for location and how to get it out of the lexer. So the lexer is supposed to give us a tuple. Not just the token, but also the beginning and ending locations. And I think the location could be any type. So what I prefer is a line and column numbers, because that's what I had in the C code. Let me see where that was. Callbacks, I think. Yeah. So there's first line, first column, last line, last column. That's for an error. And I guess non-errors did not retain their locations. Yeah. Okay. Errors did, though. In fact, what if I look for the word column? Too many matches. Okay. Oh, there was a general injection. We would put it in first column. Okay, where's first column? Okay, statements recorded their column and line numbers. Did I say why? I didn't really say why. So for errors and for statements, we recorded the locations. And it's leveraging this user action from the lexer. This YY column, how did we maintain that? YYLENG, what is that? This is the only place where YY column shows up? This is some kind of internally maintained thing. Okay, so just that option of the lexer maintained it for me. Huh. So I don't know if Logos is going to do that for me. I might have to look that up. So yeah, before I get too far, I kind of want to make sure that I do this correctly. Okay, there's something called a span, but I think that's like a character count, which means it'd be up to me to maintain line number versus column number from a span, right? Ridiculously fast. How fast? Ridiculously fast. Let's look up span, see what it says. Gets the range for the current token in source. A span is a range use size byte range in the source. Oh, that's terrible. So byte range means that we'll have to know how to map that to character range first. And then we'll have to like be tracking all the new lines. And whenever we see a new line, we go back to column 0 and increment the line number. So we have to do that ourselves? That's terrible. So one way I could do it is to preprocess the file and construct a mapping between byte positions and the beginnings of lines. Maybe even byte positions and line column numbers. You actually did this sort of thing recently in your compiler if you want to link the lexer implementation. Did you have to do it yourself or did Logos do it for you? Because I'm used to Flex doing it for me with this option. It would seem like something you'd want any user of this crate to do for you, or any user of this crate would want, right? What are these things? What? What? Current token becomes the error token of the new token type? Huh. It's not actually that hard. Yeah, I was thinking I would need to pre-process it. The problem that I see is that we're doing it all declaratively as macros, right? So if everything is declarative, well, hold on, that's not all declarative. I had to do a little bit of wrapper around it here. We had to give the lexer the entire input. So I guess this would be, before we give the lexer the input, we'd have to also look at the input and split it by new line, right? And then get a byte count of every line. Or maybe we just retain the input. I know, we would retain the input so that we can actually get the slices that go for each line, and then we would just have a count of from byte to line number, and so that when we get a span out of the lexer, we can just focus in on the line that it's in, and then because the hard part is we got to go through every single character of the line to figure out what the byte offset is, so we know what column the span refers to, right? You can tag the with logos extras. Context, you're untied this. Okay, there we go. That's what I was looking for. Thank you, Sarian. I didn't see that in here. Yep, that's because it's right there. Extras associated with the token. Yeah, but what do we... This can be an access inside callbacks. Okay, callbacks is another thing. We don't have callbacks. Okay. You added a token for new lines? So you're letting the lexer find the new lines for you. I was just gonna split on a new line since it's easy to do. But I suppose, sure, we'll let the lexer do it because it's already scanning it for me. Would this be easier to do if you delay the line column finding to after you actually hit an error? That's what I was thinking, that you would be lazily evaluated. So I'd retain the idea was I'd retain the input and then wait until I actually need a location mapped back to a column and line number, and then I go back to the retained string and at first focus on the line number by we'd have to split, or like Sarian saying, let the lexer count new lines for me so that I could at least know the location of the first character in that line. Then we'd have to, I think, because the lexer wouldn't do this for us, we'd have to map characters to byte offsets in order to get the character offset or the column from the byte. So yeah, I think Sarian's probably doing it the best way. Let the lexer tell us the location of the beginning of each line, and then if we've retained the input, then when we need a location like alienated worker is saying, we would then go back to the retained input, find that line, and figure out what column the locations are in. And I guess we'd want to cache, well, if we could, if we wanted to, we could then cache it at that point, right? So how does this work? Oh, lexer with extras. Create a new SS lexer with bright extras that will produce tokens implementing this logos. Okay. And again, extras is an associated type. Okay, but what about this callbacks? I'm looking for the callbacks. Oh, is that what they mean by callback? They mean the this? Okay. So right, like when we're doing string, we get a token, but now we'd the token would have something attached to it. Okay, how do we get access to those extras? I don't really get what you put into extras. It's the associated type, and we have to give it we have to have a value that we give it when we're parsing. The field storing the extras is public. Storing it in what? In Lexer? Ah, here we go. But extras is just a constant for every token, right? So it's whatever value I give it there, it just copies it for the token, right? So this is like has to be it's a type, but then this is a value right here. Yeah, but how does that help me? What would I put in extras that would help me? I guess. I thought the callback did give me a token. Oh no, you're right. It gives me a Lexer. Okay, so it gives me a Lexer, and I'd be able to get to the extras. But what would I put in extras? Are you suggesting that I would put the original input in there, or I'd put some kind of reference to an object? I guess it wouldn't need to be referenced. It would be the object, right? For so take this input and stuff it into the extras in some way. Create a struct that start the current line count. Current line count. Yeah, but how do you? It's not mutable, is it? That field is not. Oh, is it? Is the Lexer mutable in the callback? Where was that again? Token. It is mutable. Okay, so we can change it. I see. So you had a callback for a new line where you incremented the line number. Okay. And then you'd use the span of that new line to know where it was. You can't store non-static lifetimes in the extras. Are you sure? I thought the whole thing was across an input lifetime. So you're saying that I can't make the type of extras. Is it extras or extra? Extras, right? I can't make the type. I can't make this reference in. I guess we'd have to name it, right? Oh, that doesn't go there. It goes. Where does it go? Wait, hold on. I'm a little bit confused. Oh, it's associated with the generated code, so I have to do this thing, right? Yeah, so I would put it in token. Around here somewhere. Here you are. There, right? So you're saying I can't do well? Oh, I see. Because it probably doesn't. This doesn't work, right? Because it doesn't know what that is. Undeclared lifetime name. You ran into this? Yes. A derived macro doesn't. Yeah. Lifetime name isn't. Oh, how sad. We can't do that, so we have to have something else. Ultimately, what do I need? What do I have available here in, not there, in here? Not there even, up in here. I have to put all my context in there, right? So I have to have, my input has to be, what, do I have to clone it or something? Let's see, what did you say you did? You created a struct to store the current line count and the start index of the current line. Yeah, but how did you not use, did you not report column numbers? To report column numbers, you have to have access to the raw string somehow to figure out how many bytes are in each character in that line. So you'd have to go back to that part of the line, right? Or sorry, you'd have to go back to the input where that line starts and start counting characters. Yeah, I guess at this point, if you have a link, I'd look at it. You store the line count and the index of the start of the current line. Yeah, but then how did you get back to your input? When you asked Alexa for the next token, then I handled it there. Oh, you mean like here. There we have access to our input. I see. Okay. Yeah, and then we kind of know which tokens need to have the location information in them, right? Well, I guess we could just generate the location information of every token. So self-lexer next. We could see if it's a new line token, we could extract the line number out of it. And if it's a, actually, I don't even need to put the line number in the extras, do I? I don't need it. I don't need extras. Because if we're going to be manipulating the input here, all I just really need to know that is if the token is a new line, then we need to reset our column number and recalculate our slice for the current line. Well, I guess it would be from the current position to the end of the file because we don't know how long the line is, right? So when you ask for the next token, you can also get the span. Yeah, exactly. But you can use, yeah, so I don't need to put it in the extras. I can just make it, since it's a mutable self anyway, why don't I just put it here for line number. U size, because I can. And then we'd have to remember the I guess it would be our current, the line start, right? And then well, every token's, well, actually there might be white space that we skip, right? So I guess we want column number. Actually, then I don't need the line start. I want to say like position. So the position will have a line number and a column number, and we just move forward. So I need to remember the position and the what do they call it? The byte offset? Span? They call it the span, right? What type do they use for span? Range. Byte range in the source. So this would be like byte number. Right? So these would all start at 0, and this would start at input. And then every time we get a span out, we would need to, from the position, we have to count characters until we get to that span, and then that would update our column number. If we get a new line, we reset that to 0 and increment that one. Yeah, I'm taking advantage of the fact that I wrapped it in my own type for abstracting away the implementation from the interface. If the interface is just iterator, then I needed something. This is basically my iterator, and then I have the opportunity to store that there, so I don't need the extras. So we don't need you extras, sorry. Okay. I only have 5 minutes left. I don't think I'm gonna actually get this done, but we'll see what we can do. Yeah. Copy. Link. Paste. Link. You called it here for a new line? Line number. Start minus that. What's in turn? Something else? Okay. Sounds good to me. Gives you a string of the current source location. Okay. Fill struct fields. So normally I would alphabetize these, but I'm actually starting to think. Actually, maybe I should alphabetize them, but these are all related to each other, so I should put them in a substructure, right? Called location. Location. Yeah, why don't I just let this structure figure it out, and I move this into there, and then I call this location. Right, and then I can get rid of this stuff. And then this, I can make this be like a new. So impl, this will have to be generic off of some lifetime because we have the string in there. Position, or I guess we'll call this the input. String. All the to-dos are 0. Except for position, which is input. So this is location, new input. Yeah, we're not using it yet, but we will. We will. Token. Actually, I don't really want a token, do I? Oh, I want a token, but I want to discard it from the grammar. So maybe I put that first, and I say this is a special token. So special token for counting lines, input lines. Discard. Don't pass to parser. this has to be defined as like a regular expression, right? So this is like line end. Okay, and this is line end. So the regular expression, isn't it just new line? I don't double escape that, do I? Or do I don't double escape that. Right, because we're already saying it's raw. So it's escaped for the regex, but not for our string. Right. It used to be a token, not a regex. You're matching a literal. Oh, right. Token is a degenerate regular expression, right? Forgot about that. And I should have seen that. But token can have a callback, you're saying? Because I didn't have that up until now. But I assume that's what you meant. So we'll have a function in here. Let's just put it at the top. And then this expects nothing, right? Okay, so then actually I don't need a callback. What am I doing? I don't need a callback. I would have needed a callback if I wanted to get access to the extra, but I don't even need that. So I just need to do it here, right? So unwrap. So I need to do a if let line a token line end. If it's a line end, we want to loop back, right? So then I'm going to want to do a loop, right? And this is a return token or break token. And this is a continue. I don't think I have, oh, because I'm missing this. Some. Break is better than return, right? Just in case I wanted to let that be something and do some post stuff. Okay, so line end. Yeah, here's where we want to do self dot location dot line end token dot span. Wait, there's no, we can't get a span out of it? Oh, is it self flexor span? Not self. Okay, how does the span thing work? Get the range for the current token. If there's a range, okay. Range. So it'll just be a single byte in this case, right? Oh, it's here, right? Function line and oh, I gotta stop because I gotta go work. Span, range, usize. ops range, I guess. Okay, so that builds. How about for now we'll just print ln line end at span. Okay, and then let's cargo build, and I'll just run the lexer. Too many things. So I'll do target. There we go. Did it not work? I'm not seeing it in there. It didn't ever see it. Oh, is it no, wait a minute. I saved it, right? In token? Why is it not seeing line end? Yeah, it's not seeing line end anywhere. Well, actually, it wouldn't print it, would it? Oh, there's the conundrum, I guess. Is the that line end should be called here, but it's never seeing it. Oh, is that why? Thank you, because I would have left that for tomorrow. We don't want to skip new lines anymore. Illegal? It says it's illegal. Why is it illegal? Actually, we don't want to do this, do we? That, because we wanted to count the line number. I know, what? What? It's illegal. I don't have enough time to figure it out, though. You got an R string. Oh, because it was for regular expression. Yeah, you're right. Okay, that's probably it, right? Yeah, that's right. Sarian's always like coming in as a clutch at the end there. Yeah, there we go. There's our line ends. Actually, if I wanted to make it print really nicely for myself right now, I would go to here and do another print line. Because just that, right? Actually, I don't need to say print. I don't have to say anything in there. Okay. There we go. And now we're getting our spans in there. So GIF, left brace, and then line ended. Semicolon, line ended. Nice. Nice work, yes. That's why Sarian's name is on my keyboard. You see that? If I move it correctly? Okay. You probably can't see it, but Sarian's name is on there. Thank you, Sarian. Yeah, we'll be back tomorrow to, I need to take these spans and then update the position, and then we use the position later to, we're going to be counting line numbers, right? And then we'll be finding the counting column numbers as well. Probably this span of every token will then move the position over, being counting columns and stuff like that. So we'll be doing that tomorrow, and then I'll have location information baked in from the lexer output, and then I won't be perpetuating this sort of bug where in all of these tests where our locations are all units. We need to actually have real locations in there. because we'll eventually want them anyway, and why perpetuate this garbage when we can fix it? So yeah, I got this thing called work now I have to go do, unfortunately. So Primogen's not streaming today? Oh, I made some kind of Twitch achievement. People know me. Achievement completed. People know me. Okay. Tuna Fudge Face. Thanks for being here. Lana Lux is on. Okay, I don't follow Lana Lux. But feel free to switch over to Lana Lux now. If you don't have an opinion, we'll just go watch Tim. All right? Okay, she's a Unity dev. That's cool. Feel free to switch over to Lana Lux, but if you have no opinion and you just want to be swept off your feet to another channel, then we're going to go see Tim, okay? See you guys tomorrow. Thanks for being here. Bye.